We're picking up with the note sheets where we left off yesterday. So, we were talking about translations yesterday. So, K tells us a vertical translation up or down. Our vertical translation is exactly what it looks like. Because if we have +3, it's up 3. If it's -7, it's down 7. We also had horizontal translation. It moved the function to the left or to the right by h amount. Now, horizontal translation, we had to be a little careful because it went in the opposite direction of what we thought. Because the absolute value of x minus 5 is not moving at 5 units to the left, it's 5 units to the right. The same thing is true with x, the absolute value of x plus 5. Seems like it should move to the right. It's actually moving to the left. Left and right is the opposite of what we think. A, if the value of A is negative, not so much the number, we're talking about the value. If it has a negative sign for A, it's a reflection across the x-axis. We're not looking so much at the number, but the sign of that number. And then where we ended, we didn't do any problems with it, was our vertical stretch and vertical shrink. Now, we said a function had a vertical stretch if the value of A was greater than 1. Not looking at the sign, looking purely at the number. Because if the number there is 2, 2 is indeed greater than 1, we would say it is a vertical stretch. Now, we said it was a vertical shrink. If the value of A was between 0 and 1. And really, we talked about this yesterday. So it'd be more of the absolute value of A than the number itself. Because the negative, the sign attached to it, the negative sign is telling us it's a reflection. The number is telling us if it's a vertical stretch or shrink. Does that make sense? We can distinguish between those two. Because the textbook definition is that we're talking about the absolute value of A because we're not looking at the sign, we're looking at the number. So if we look at this first one here, g of x is equal to 2 times the absolute value of x. Well, the parent function is the absolute value because we're talking about the absolute value function. Does that make sense? Now, if we look at the general form, A, absolute value of x minus h plus k. Do we have a value of k other than 0? No. So that means it's not moving the function up or down. Is there a value for h? No, so the function isn't moving left or right. Do we have a value for a? Yes. Is it negative? No. Since it's not negative, it means there is no reflection. But since it does have a value of a, and that value is 2, is 2 greater than 1 or between 0 and 1? Greater than 1. So it's telling us this function here has a vertical stretch of what? 2. How much are we stretching it by? And we do the same thing with shrink. We say, what is the factor, what is the scale that we're stretching or shrinking the graph by? So our blue graph here is the parent function, y equals the absolute value of x, or f of x equals the absolute value of x. Thank you. And the one in red is our vertical stretch. We're increasing the values of y by this amount, by this factor of 2. And when we stretch it vertically, it's going to increase faster. The values of y are going to increase or get bigger quicker. So graphically, it looks like the graph is getting narrower because we're pulling the two sides of the graph up along the y-axis. And the bigger that value is, the faster it will increase. So if we said 9, we can see that it's a lot narrower. The bigger the number, the narrower it gets. But that also means that a vertical shrink means that it's going to get, or should get, wider, yes? This one's actually very wide because we're stretching, or we're shrinking it by a factor of 1/19. Okay, so every value of y is increasing 1/19 of what it would. So if the value was, say, 1 for y, it is now 1/19. That also means if the value of y was supposed to be 19, it is now 1. So normally, it would take us moving 1 to the left or 1 to the right. When x is 1, we would get 1. 1/19 now says when x is 19, y is now 1. It is a lot wider. Questions on A before we look at B? B, what's the parent function for 1/2 x squared? It's a quadratic. A times x minus h squared plus k. So if we look at this here, is there a value of h and k? No. Value of a. Is it negative? No, so there's no reflection. If it was negative 1/2, we would indeed have a reflection across the x-axis plus our vertical stretch and shrink. But the value of a is what? 1/2. Since 1/2 is indeed between 0 and 1, we have a vertical shrink of 1/2. That's it. Questions on A or B before we look at 5? Number 5, what group or what parent is it? It would be linear, it's line. And for the most part with lines, we don't have a left or right movement. We're mainly going to have vertical stretch, shrink, reflection, or up, down. We don't really have left or right when we're looking at the function. No h, no k, but a is 3. So that's showing us that we have a vertical line. Is 3 bigger than 1 or between 0 and 1? Bigger than 1. If it's bigger than 1, it's a vertical stretch of 3. That's it. Number 6. H of x equals 3/2 x squared. This would be quadratic. H and k, do we have a value for either? So, no h and k, but a is what? 3/2, yes? Since it's a fraction, it means it has to be a vertical shrink, yes? 3/2, is it bigger than 1 or between 0 and 1? Bigger. Because what is 3/2? It's 1.5, yes? So since it is bigger than 1, it's not going to be a vertical shrink, it's going to be a vertical, what? Stretch of 3/2. Just because it's a fraction doesn't mean it has to be a shrink. We have to make sure that the value is indeed bigger than 1 or between 0 and 1. Might need his glasses. Glasses. Number 7, 0.2 times the absolute value of x. Well, the function is in absolute value. Kind of gave it away. Yes? Now, again, we don't have a value for h or k, but we do have a value for a. 0.2. So would that be a vertical stretch or a vertical shrink? Shrink, because 0.2 is indeed between 0 and 1. So it tells us this function, we've applied a vertical shrink of 0.2. Questions on this here? Ready for the next one. Identify the family that the function belongs to, and then compare the graph of f to the graph of its paired function. All that's saying, what is the family for the function? Describe the transformation. So what's the family for this one here? So what family of functions does this belong to? Absolute value. Because we do have the V-shaped graph, also we have 2 times the absolute value of x plus 1. Fix that. Write the general form. Do we have a value for h? No, just x. We don't have anything being added or subtracted from x inside the parentheses. Do we have a value for k? So that's telling us it moves up or down. What are we moving? Up how far? Up 1. Because since it's plus 1, outside the absolute value bars, it's telling us it's moving up 1. Yes? All right, so we're done with this one. Are we finished with this problem? Is there a value of a? Yeah, so a tells us that there could be a reflection across the x-axis, yes? Is a's value negative? No, so there is no reflection. If it was, we could have a reflection. But a's value is 2, yes? Which means there has to be a stretch or shrink, yes? Now this here would be a vertical stretch of, at this point we're used to being one transformation. There's only one thing that's going on. We can have more than one. Here we have 2. We have the movement up and down, up 1, and we also have the vertical stretch of 2. We can have more than one thing going on. Identify the functions family and describe the transformation. So what family of functions would this belong to? Maybe a quadratic. Since it's quadratic, we'll write the general form. A times x minus h squared plus k. Do we have value for k? Moving it up or down? No, there's nothing added to the end of it. Do we have value for h? Moving left or right? X minus 3 inside, yes? So there is a movement left or right. How far are we moving to the left or to the right? 3. Now which direction are we moving? Opposite of what we think. So since it's negative, it could be to the right. The value of h is actually positive 3. X minus 3, 3 units to the right. If it had been x plus 3, it would be 3 units to the left. Do we have a value for a? Is it negative? No, so there is no reflection across the x-axis. If it was negative, there would be. But we do have a number there also, so that tells us that we have to have a vertical stretch or shrink. So what's the number? 1/4. Is that bigger than 1? Is it between 0 and 1? So it has to be a shrink of 1/4. Questions on this here? We're ready for the next one. G of x equals negative absolute value of x plus 5 minus 3. Well, this here is absolute value. Okay. Do we have a value for k? Yes. So that's telling us it is moving up or down. Where are we moving? 3 units down, down 3. Do we have a value for h? Yeah, so we do have a movement left or right. How far are we moving? Left 5, yes. Do we have a value for a? Yeah, we have a negative sign there. Since it's negative, it tells us that there is a what? Negative. If a is negative, there is a reflection across the x-axis. Is the value of a, the number for a, something other than 1? No, it's negative. It's just 1, yes? So that means there's no stretch or shrink. Vertical stretch or vertical shrink. If it had been, say, 2, we had negative 2 in front of that absolute value, the negative would tell us it's a reflection across the x. The 2 would tell us a vertical stretch. We see that there? H and K tell us one thing. H tells us we're either moving up H is either left or right. We're doing one or the other. K tells us we're moving up or down, one or the other. A is either vertical stretch or shrink or reflection, because we can have both. It can stretch it or it can shrink it vertically and reflect it. We can have both of those. Because if we look at this last one here, it is a quadratic. But if we look at A, well, we are going up 4, is our plus 4. A has 2 parts. Is we have the negative and the 0.25. Since it's negative, is A negative? Yes, if A is negative, it is a reflection across the x-axis. But we also have a value of A of 0.25, yes? The negative tells me there's a reflection. The 0.25, A is between 0 and 1, tells me that there's also a vertical shrink of 0.25. So we can have both. We can have a vertical shrink, vertical stretch, either one, depending on the number, and a reflection. We can have both of those. Questions on this here? Homework 3 through 5. So problems 3 through 5. You're naming what type of function it is, what parent function it belongs to. Describe the transformation. That's all you're doing. 3 through 5. 9 through 15 odd. So 9 through 15, you're only doing the odd one. So 9, 11, 13, 15. Those there. Name the parent function. Describe the transformation. Hopefully you're starting to see a pattern. Do not graph 9 through 15. You're not graphing at all on this homework. 19 through 25 odd. So 19, 21, 23, 25. Name the parent function. Describe the transformation. 27, 28, 31. Name the parent function. Describe the transformation. That's it. That is the entire thing. All of the problems. You're naming the parent function, describing the transformation. Do not graph. I am not asking you to graph it. You can if you want to, but that's not part of the assignment. That's it.